Differentiation is a very commonly used concept in mathematics, a very popular topic in calculus, which we're going to look at now in this series. The first thing we need to do is look at the definition of a derivative. From there, we're going to look at some differentiation rules, some shortcuts to make it easier, but we first have to see where it starts. So if I look at a curve, and I want to find the gradient of a tangent line to a curve at a point. Let's say I've got that point A. My y value, if that is a function y equal to f of x, my y value is f of a. Now I want to know what is the gradient of the tangent line at that point. Now to find a gradient of a straight line, we need 2 points. So to look at that gradient, we start off by saying, okay, I can't just get a gradient with 1 point, so let me pick another point. Now, we imagine we're zooming in, I'm picking a point B here. So then rather than looking at the gradient of the curve at A, I look at the gradient of the straight line between A and B. We say, okay, we're going to compromise a little bit, and we're going to look at between A and B. So then that gradient, I'm just using m for gradient, is the difference between the y values divided by the difference between the x values. So that's my gradient. But now I'm saying, wait a minute, that's not exactly the gradient I was looking for. So let me move B a little bit closer to A. Let me take B and move it a bit closer, and we pick something over there. And then obviously we move a little bit closer, till we're so close to A you have to zoom in very far to actually see the second point. But we always need 2 points to find a gradient. So what we do is we say we want this distance from A to the next point to be as small as possible, whatever that point is. So what we're saying is, let's make that distance h. So then I've got my point A and my point A plus h. So then the gradient between those 2 points will be f of a plus h minus f of a divided by a plus h minus a. We can simplify the denominator, that's f of a plus h minus f of a divided by h. So that will now give me the gradient of the straight line connecting the dots from between a and a plus h. Now we've got a concept in mathematics called limits. If you're not familiar with that, there'll be a playlist on limits on this channel, so you can go look at that. But what we're looking at is we want to see, I want to make h as small as possible. I want to get it as close as possible to a. But now remember, we can't have h 0. We can't find the gradient of a line with just 1 point. We need 2 points. So we're going to look at the limit as h approaches 0. So it never gets there, but it gets so practically close to 0 that it doesn't matter. It's insignificantly close. So the limit as h approaches 0. That will then be the gradient of f of a plus h minus f of a over h. So that is what we then use to find the gradient of the tangent line of a at the tangent line at the point A, because we're saying that h is so small that it actually doesn't make a difference. Now, this is what we call the derivative of this function at the point A. We can also think of it as rate of change. Remember, rate of change is the change of the output value divided by the change of the input value. So we've got change of y over change of x. So rate of change, gradient of the tangent line, and differentiation all point to the same thing. So let's formalize the definition of the derivative. If I've got a function f, the derivative of f at x, we denote it by a prime. F prime x is the limit as h approaches 0 of f of x plus h minus f of x over h. All right, so that's the formal definition of a derivative. Then there's lots of notations, and you need to be familiar with these notations because it can be used interchangeably. It's better when you do work that you pick a notation and stick to it, but if you're encountering any of these notations, you need to know what they refer to. So all these notations at the bottom refer to the derivative of the function f. Just note that is a prime, it's not an exponent. So those are all ways to denote the derivative of a function. So let's now look at how to use this definition to get some derivative. So in some people call it using first principles. We're using the definition to get the derivative. So we've got our function g of x given here as x squared plus 5. So if I use this definition, then the derivative of g of x is the limit as h approaches 0 of f of x plus h. Now we've got g rather than f, but g of x plus h, meaning x plus h squared plus 5, minus g of x, always put it in brackets, x squared plus 5, especially if there's more than one term, divided by h. All right, now this limit, we're not taking the limit right up to the end. We are just doing algebraic manipulation on that fraction. So you can square out, simplify, and you'll end up with x squared minus x squared. We'll end up, they're going to cancel out, plus 5 minus 5. So we'll have a 2xh plus h squared over h. If you're not happy, pause here and write out the simplification of that fraction to make sure you get that. All right, now we can take h out as a common factor. So we've got h times 2x plus h over h. And we know that limit is then the same as the limit as h approaches 0 of 2x plus h. So now h is approaching 0, so 2x plus h approaches 2x. And that's the derivative of g. Now, if you know some of the shortcuts, some of the rules of differentiation, you would know how to find the derivative of g of x. But you need to know where it comes from. We are going to look at the rules, but you need the background first. So that is how we use the definition to find the derivative of a function. I'm going to do one more video on using the definition or first principles, and then I'll move on to the rules.